Okay, welcome back. This is Applications of Calculus 2. We are going to do a Newton's method problem. This is going to be kind of rough on me because I have limited space to work with. This is going to be a little bit easier for you folks than it is for me because you'll be able to see the whole paper at once. Okay, so we have a problem here. Okay, it's on 0 to 3, Newton method. Estimate your solution to two decimal places. Very good. You will also be afforded Newton's method on the last page of the test. Go ahead and look for it. It's going to be right there. Okay, so let's go ahead and get this guy started. So we're going to say, all right, we need a couple of things before we're going to start here. We're going to say f of x. Let's go ahead and turn on the pen. We're going to say f of x is equal to, and let's see, we have 4x to the 1/3 minus 2x squared plus 4 and equals 0. So we're trying to figure out where does this cross the axis. Okay. One of the things that we're going to have to do is we're going to need our derivative. So we're going to go ahead and take our derivative. It's going to be 4/3 x to the negative 2/3 minus 4x. Derivative of a constant is 0, of course, and that's going to be our f prime of x. Okay. The next thing we're going to need to do is you need a starting place. Okay. We were given it's on 0 to 3. You're allowed to pick these numbers. That's fine. The further away from the actual value you get, the more of these iterations you're going to have to do. So I would pick something in the middle that's easy. And I was like, oh, well, 1 is freely available. Let's pick 1. Okay, and see if that go ahead and works. So what we're going to do is we're going to say that C2 is equal to C1 minus f prime of C1 over f prime of C1. Okay, so we're just going to do that. So we're going to say that my C2 is equal to 1, okay, minus, and I have f of 1 divided by f prime of 1. Okay, that's not too bad. Let's go ahead. And I wrote all of this stuff down because there was no way. I tried to do this on screen a few times and realized like I need a script. So we have that. So if we type in the 1, we have 4 minus 2 plus 4 divided by 1 raised to the 2/3 is just going to be 1. So I got 4/3, okay, minus 4. 1 times 4. All right, so this was going to be 1 minus, and we have, this is going to be 6 divided by, and it looks like we have negative 8/3 here. Okay, so we go ahead and do this arithmetic. It comes out to be 3.25. Okay, now this is the next value that we're going to be dealing with. Okay, this is my C2. So C3, okay, is going to be 4 times 3.25 raised to the 1/3 power, okay, minus 2, 3.25 squared plus 4, all divided by, okay, and this is going to be 4/3, 3.25 to the negative 2/3 minus 4 times 3.25. Okay, let's see if we go through and do all of this. If I go through my top one here, it goes C1, C2 minus this thing. Okay, so 3.25 minus all of these pieces. All right, so let's see. I ended up with doing this. I got 3.25 minus, and then what did we end up with on the top? This was delightful. 2,000, 786. Okay, all divided by, this was 12 point, okay, 3923, 085. Okay, carefully typing this into the calculator, I ended up with 2.346, 212,957. Okay, so we're going to have this value right here. Now, right here, we have to figure it out to 2 decimal places. If you kept 3, you're probably going to be just fine. Okay, keep 4 just to be safe. You don't have to keep all of these. I wasn't sure how much round off I was going to have, so I kept them all just to make sure. But I think if you keep 4 of these guys, you'll be fine. Okay, So we'll go ahead and say, okay, well, that was my C3. Okay, that's my C3. C4, okay, so we're still working on this, is equal to C3 minus, so this is going to be 2.346, 212. Where are we? 346, 212, 957, 957 minus. And we're just going to reevaluate this function again. So it's going to be 4 times. Okay, 2.346, 346, 212,957, 212,957 raised to the 1/3 power minus twice 2.346212957. Okay, squared plus 4, all divided by, and I'm evaluating f prime at this point here. And when I did, okay, so we're just going to type that in. So this is 4/3, and we had 2.346212957 raised to the negative 2/3 power. Be careful with parentheses here. Minus 4 times 2.346212957. Okay. I went through and evaluated all of these things. So let's see what I end up with at the end here. I got, there we go. It's right here. So we ended up with, this was 2.346212957 minus, I'm sure this is delightful. These both turned out to be negative. Top and bottom turned out to be negative. So I have 3 negative signs. We're going to keep the 1, okay? Because we have 3 negative signs. Negative times negative times negative will be negative. And I ended up with 1.694. 694. Okay, I'm just writing all of these down just in case you want to follow along and you want to try a couple of these on your own. Okay, we're just making sure we're all getting the same answers with this. And at the bottom, I got 8.629, 712, 712, 451. Notice how the bottom has always been bigger than the top here. So we're getting smaller and smaller. We're changing this by a smaller and smaller amount. Okay, and that's kind of what you're looking for. Okay, this turned out to be 2.346212957 minus, I just took this ratio, and I got 1 point. 1 point? I got point. There it is. 0.196330656. This was equal to, and we got 2.14988. Okay, 2301. Okay, so we are up to here. This is now my C5. Okay, so it's taking a little bit longer than I really thought it was going to, but there we are. Okay, for C5, we're almost there, I promise you. Okay, actually, we're not almost there. We have 2 more to go. Okay, because it converges kind of slow when we have this thing, but we are close. Okay, 2.13. So again, we have to turn this crank again on this whole thing. I'm going to go ahead and skip to the part we have. We had 2.346212957 minus, and then we had this whole thing being minus, this was 0.0104. Okay, 41028. It's changing in the second decimal place, so we're almost there. And I ended up with, that's 234. Okay, hold on there. 234 for that one. The next one I got, okay, 234. Okay, I got, there it is, 214. 2.14988. Okay, 2301. Can't remember doing this in the airport for a lot of hours because this was back in the 90s and there was nothing to do in the airport. I mean, once you finished reading your book, your magazine, like entertain yourselves. There's no phone, there's no nothing. So I was caught there for several hours. This is what I just found, the square root of 2 to an obscenely number of decimal places. Nobody in the airport wanted to talk to me. So that's exactly what I wanted. Okay. It's probably a reason. I probably wouldn't do that today because this was definitely pre 9/11. The next value we're going to get, okay, is we're going to run this whole thing through this whole process again. So the next one I ended up with was 2.13944, 13944. Okay. 1273, 1273. Okay. We're still changing in the second decimal place, kind of. So I would do this one more time just to make sure that we ended up with it. So we are there. If I run through this one more time, okay, I ended up with 2.139. Hey, nothing changed. 142623, 2623. We are not changing anything more than the third decimal place here. This is not going to change in the third decimal place forward ever again. Okay, so it says round off your answer to two decimal places. I would say, okay, let's look at this as 2.14. Call that an answer, and that would be our solution for this particular problem. Okay, again, you probably only have to go out about 4 decimal places for this thing to not have to worry about any round off error. I would be safe and go with 4 just to make sure. Okay, 3 if you want to risk it. 2 is probably not quite do it. Okay, but that's what you're going to be looking for. And when it ceases to change in the place where you're supposed to look for, that's when you know you're done. Okay, so I hope this was helpful, and I hope you guys have a much better time with this problem than I did. But yeah, it was a good thing for everybody to do. So Newton's method is not so much needed in the 21st century, but you never know. You might have to write a program someday where you have to find zeros and you don't want to pay somebody else for their program. You might have to do this one on your own. So this is how it used to be done to find zeros of polynomials. Okay, so I'm going to say go ahead and thank you very much for watching the video. Good luck with your test, everybody, and take care.